Okay. All right, so to begin this meeting, I'm going to do a presentation on Wireshark, and this is one of the introductory tools that usually comes with Kali on your machines, which we touched on last time, installing Kali and getting all that set up. All right, so basically overview for Wireshark began as a tool for tracking known network problems in 1997, since there was no tool that really filled that niche for TCP, IP, and kind of going over all that and scanning your network. All right, so originally called Ethereal, 2006 there were a few revisions, and it actually emerged as Wireshark after a few copyright disputes. 2008 version 1.0, 2015 version 2.0, and then it's a pre-installed tool through Kali Linux, but it's also available for download through Windows, Microsoft Windows like 10, 8, etc., or Mac OS. All right, so one of the things of Wireshark that you kind of need to know is explaining packets. So packets are essentially the units of data that are sent between two different computers. So one data image, which is broken up into packets from computer A, it's broken into pieces, and then these packets are actually part of an image. And so computer A, this is basically how data is transmitted from A to B. So it's the initial image broken up into packets, sent over to computer B, and then reformed into the actual image, which is created back into for computer B, and then it reassembled at computer B. All right, so I'm going to go over the three-way handshake and TCP or transmission control protocols, which are essentially what most internet servers and how your computer usually functions for this type of thing. All right, so the first is SYN. It's the first step, so sign, and then the active open is performed by the client, sending as a SYN to the server. So the SYN is essentially the request from the client to the server, and it's requesting a solid connection between the client and the server, and then this is used to achieve a connection between the client and then the open ports, which the server is listening to receive data and receive a transmission from the client. And then this is only in the first packet for the initial establishing itself between the initiator and the receiver, to the client and the server. And then the second step, which is called SYN-ACK, the server replies. This is the server replying back to the client. And so the server allows the connection to proceed further, and is basically the server acknowledging that it just received the first packet from the client. And then the SYN-ACK overall is the packet is sent in response to the connection request. So it's basically sending data back to the computer. And then the final step is the client acknowledging that the packet that was just received was actually received. And so then that leads to the actual data transfer being able to begin. So as you can see over there, the SYN is sent, then received, and then the server sends the SYN-ACK back to the client. And then once that's received, the connection is established, and then the acknowledgement is sent back to the server, and then the connection is established. Therefore, data is able to be sent back and forth. All right, so then I'm going to go over into a demo in just a minute. So for going over how to begin, get up Wireshark, initiating capture, interpreting the data on the screen, doing different search queries, and then I'll explain what those three at the bottom mean in a minute. All right, so those of you who don't know, Wireshark is this little blue icon. So you go in your applications, and then just type in Wireshark. It doesn't really matter which one you do, but I'm using the first one right there. As you can see, I already have it pulled up. All right, so I did one earlier. So I did it. This is scanning from my own computer. Usually, as I have it, my privacy settings, I cannot just scan on Maryville's network. I'm only doing it through the traffic that's going to and from my computer or my Kali Linux VM outward to whatever I'm doing. So this was earlier on my Mozilla I was doing. So as you can see here, I just did a search query for CNN.com because it's usually best to do it on a website that you haven't visited before. So I just cleared my history and just went to a site that my Mozilla hadn't remembered or anything like that. All right, so as you can see here, the DNS protocols these are blue, and then the TCP traffic, which is the three-way handshake, which I addressed on earlier, is the green. And so, right. Yeah. All right. Okay. So as you can see, right. All right. So the port for my computer's port was the 56,764. This doesn't really matter as much. This is basically just how your computer, or the source, in this case, the source is my computer, transmitting out, and then on the receiving end, which is port 53, which is the port for the DNS protocol. So 53 is the one that is receiving the data on the server's end. So that's the part one of the handshake, or not the handshake, sorry. This is basically my computer querying the CNN server to get to it. And then, so as you can see, the destination right now is the other server, and the source right now is my computer. But then after it processes this, it switches. So the 192.168.11 that flow flops, and so then my query is being pushed back to me to actually load the site. So the original destination is being pushed back to the source, and so as you can see, the destination has changed to be the source now, and the destination has changed. And additionally, the source port now is 53, which is the original port. So it's sending back data along that port, which was the open port on the server. And this is the port that my computer is using. So my computer is now the receiver of that data. And then all right, then for TCP, as you can see, all right, so for here the port is completely different. So this is the TCP. So this is going over the SYN ACK. So what's that? So this is the first step in the first step. Let's go to the second one, and it's the third step, and then finally, after those are all complete, then it begins the encryption process. So as you can see, it changes over to TLS, which is essentially, you guys know what HTTPS is, where it's like the secure encryption for websites and such. So right now, after the initial TCP outward like request and getting the data, the client, which would be the servers that I'm trying to get to, acknowledges that I'm trying to contact it. I'm basically reaching out, and then here's the server receiving that message and getting it back. And then after that, as you can see here, the SYN, then ACK, and then the ACK. So these are the three steps for the TCP handshake. And then one other thing. And as you can see, you can kind of like, these are all the steps that normally it goes through to get to a certain web page. As you can see here, and then here is the secondary server. So A was the primary server that I was trying to go through, but usually if websites have like two different ways to get to them, like if one website links to another, that's the example here. So this is the like primary website, so CDN, CNN.com, and then this other one with the 4 A's is like probably their hosting or something like that. So usually that is like a kind of like a way of redirecting you. And then, okay, and then here also, as kind of like the site started loading, these are like cookielaw.org, stuff like that. These are usually like the ads that kind of pop up. So it kind of like demonstrates how much goes into the goes into actually like loading all these protocols and getting all the data for the websites. All right, so let me go back. So the blue was the DNS protocols, as I demonstrated. The green was the regular TCP protocols, and then the purple, which is right here, is the encrypted traffic that after the client and server have kind of like connected and both have accepted the handshake, then they work on the protocols to get encrypted, and like the traffic can't really be like intercepted or things like that. And then pass it on to Abhi for his Linux.
Thank you, Andrew.
Which one are you using? What does it say on the top of that?
Video wall 2.
2?
Yeah.
2. So F11 will take you out of full screen. You're going to use that cable. So that's 4 box 1. So it's just watch on 4 box 1. Yeah.
First, you gotta change.
So loud.
While y'all are waiting, I just want to let you know we are watching the live stream. So if you are on the live stream, hey, you can't see me. If you are on the live stream, we can actually see your comments. So go ahead and comment so we can address your questions in real time. How do you do it?
That's the time I subscribe.
You can do it. Oh, here, I'll do it. Oh, and just so you know, if you aren't liking the video, where is it, down here? Or no, down there. If you aren't liking the video down here and subscribing down there, do it. Do you want lights so you can see the person talking?
Well, we turned it down that way if they can see the screen.
He's not gonna be up there. So
Are you not going to go up there?
No, I got it.
Okay.
He goes up there.
Okay, I'm just going to set up a light.
Okay.
Yeah. No, root. No, oh my God. Oh. No, it's Cali 1. Cali 1 tour.
Oh.
I forgot I changed these. All right, pack command.
Yeah, you're good. I'm just sending up the next speaker.
All right, ladies and gentlemen. So what I'm going to be doing is I'm going to be like basically going through how to move around in Kali and how to use different commands to move from directories and such and access certain files. So the first thing I want to talk about is PWD. Does anyone know what PWD does? There you go. Print working directory. So right now we know we're in home Kali 1. So let's say if you wanted to change directory and you wanted to move backwards from home Kali to say your base file, the first thing you would do is cd. We all know how to use that. But if you want to move backwards, you do cd ... and now we're in home file. And then ls, as you know, lists, so it'll list everything in that home file, Kali 1. So if I was to cd again, ... now we're in the base file. So the base file, as you can see, is with the dash, and this is the lowest point that you can go on Kali. There's not much that you can move from here, but this is the lowest go. So if I was to cd ... again, I would go nowhere. I'd be in the exact same place. But if I was to move forward, let's say I wanted to go to the etc file, I would cd etc. Now, if you count that right there, I didn't actually type in etc completely. I did the E and tab. So Kali has these weird quirks that are actually quite convenient, where you can actually, if this is the only working file within this base folder that starts with the E, Kali knows that that's what you're trying to go to, so it'll fill it out for you. But if I was to try R and cd R and try to tab, it wouldn't work because you have root and you have a separate folder called run. So you have to do root RO and then tab, and you can go into root. But we have been denied permission into root. So that's unfortunate. But let's say we wanted to go into etc. You could do that, cd etc, and now we're in etc. So if we were in etc and we want to look at what's all in etc, we do simple ls, and we get a list of everything that's in here. But let's say now we're in the etc folder, but I want to move into something else, like back to the home folder. Well, I could do cd into back into the dash folder and then go into root. I could do that manually. I could do cd dash and then go into home. But there's another way I can do it that's actually a lot simpler. So if I want to move from etc to home, which is not actually directly connected to the etc folder, what I would do is cd dash and then home. And what this would do is pass through the base folder and then move directly to home. And now I'm back in the home folder. And now if I'm in this folder and I want to go back to etc, or I want to see everything in etc, but I don't actually want to go into etc, what I would do is ls base, because we have to go through the base folder, and then etc. And now we can list everything that's back in the etc folder. So that's basically how you move around from location to location from directory. But there's a lot of hidden files also in Kali that you can't directly see using ls. So if I was back in the base folder and I do ls-a, -la. This shows all the hidden folders within the base folder. So these are all things that I can actually access without any problem, but you wouldn't know because, well, they're hidden. So to access, like, we have the cache folder right here. This is, you just cd into cache, no problem. But it's permission denied, which is very weird, but there's like, we wanted to cd into media. We can do that. So these are all kind of hidden, a lot of these, like the cache folder and everything. And a lot of these will be either different color or a different like highlighting. And that has a lot to do with permission or the type of folder, but we'll get into that another time and a lot of that. So that's basically how you move around Kali, but you can also do some other cool stuff. like if we're in the base folder, and let's say I wanted to create my own directory. To do that, I would use the command mkdir, make directory. And once I do that, I can just, and I'll just use my name because my name's Avi. Then boom, I can't create a directory because everything's permission denied.
Kali in the newest version got rid of the default sudo. So you got a sudo.
All right, now, okay, so now that we're in the base folder, if I want to create a directory as mkdir Avi, and now if I ls, I have Avi right here. It's a directory. And if I want to remove that directory, I do remove rmdir, remove directory, and then Avi, and then boom, that directory's gone. Now you can also do this with something other than just directories. Let's say if you wanted to create a text file. So I'm in this ls folder and I want to create a text file that I can read into. So to do that, I would do echo So basically, echo is a file is a command that outputs a string as it's being passed into arguments. So basically, what's happening here, it's echoing hi into the text.txt file that I just created. So and then if I ls, now we have the text.txt file right here. Now, if I want to access the text.txt, I could try CDing into it. But if I try to, I can't do that because text.txt is not a directory. CD can only change between directories. So the command that I would have to use is cat text.txt. And then here we go, hi. So cat is literally a command that it basically reads a file sequence and then writes them out in standard output. And it's really basically, it's called concatenating. And that's where you get the name cat from. And you can only do that with like certain text files that you're trying to read into. So you can't move between directories with cat. And a lot of times, let's just say you're in here and you accidentally say cat, and now you're stuck in this kind of weird space where you can't get anywhere. All you really have to do is Control-C, and you're back into your root folder. Now, we have that cat text file, but let's say I want to move that text file into my, let's say I want to move it into media. So to do that, I would do cp, which is copy text.txt, media. And now if you go into media and ls, now we have this text.txt file, and then we cat in the text.txt, and now we have hi. But let's say you want to remove it. Simple remove text.txt, and now if you ls, it's gone. And let's say we're back into okay, now we're back into root, and if you ls, we have nothing. That's pretty much it. I don't have much else to tell you. We could go through a lot of the commands that we'd see in the over the wire, the levels that we do, but I kind of want everyone to like kind of learn those on your own and learn how to like Google and like research and try to figure out those commands that you'll see later come in. But this will give you like a basic understanding of how to move around, and it'll supplement like your over the wire a lot, and it'll help you do a lot of this. Like the mkdir creating a directory, you'll use that in like level 12, and it's a difficult level, but this will help you a lot. So yeah, that's kind of it for me. So next I'll kind of move it on to Hunter, and he'll go over the over the wire levels that we have done. Yeah, you give it up for Hunter. We're done.
Peer pressure. Did anybody get to level 10? Okay. Cool. Oh shit. Okay. I was counting on that being on the other side. Alright. Oh yeah. Okay, so Bandit level 0. This one's pretty easy. So we kind of went over this last practice on how to really just get started with over the wire. So we'll just, can you see that? Okay. I literally just broke the HDMI cable. Shit. Oh, Hunter.
Saying naughty words. He broke the
Dude, look at that.
Oh. Did you break it?
Yeah.
Oh my god. This is why you don't pull on HDMI cables, kids. This is the same one.
That's the same one.
Yeah, can you just come closer?
Yeah.
Don't break this one.
Yeah, this isn't ours. Thank you.
Yeah. Thanks, Nathan.
It's here, right? Or no?
Yeah.
You want this one?
Trash.
What, don't want to try and fix it?
No. Yeah, really. Hunter, you sure you don't want to be in the video?
That's fine. Thanks, good over there. I just don't want to block the screen. So what I did was I switched it, right?
Did you put it on floor box 1?
I switched it from floor box 2 to floor box 1. This, like this.
Well, it shouldn't take any seconds. How's your computer doing after that? Hey guys, we're having some technical difficulties. We're gonna try a different connection to answer Ryan Davis. What is happening? Ryan Davis, we broke an HDMI cable.
By we, he means Hunter.
Yeah, by we, exactly. Here, you want to bring your computer over here and try this one? Also, make sure your display output is actually working.
Right in the middle. I might just sit down at that point.
Probably more comfy. You are right in the middle.
Is your display set up to output?
Stand.
I mean, it was working before he broke the HDMI cable.
All of it came out, I'm sure.
Did you break your output?
Hopefully.
No, because I pulled it out. I put it somewhere.
Yeah, I threw it all away.
What's up? Huh? You got past it? Nice. All right, cool. What was that?
Something loose up there.
I'm about to break your shit. Can you stop breaking HDMI cables?
All right, why don't you just come over here?
Yeah,
Then you're out of the way.
he wants to be in the middle, center of attention.
And then I'll move the light.
Swap.
Look into the lights.
That's a bright light. All right. Let's.
Where's the camera?
All right, so that it was just kind of on the bottom, so you guys can see it now. So to start with the first level, we just go ahead and open up an SSH session with the Bandit lab. We'll do that on port 2220, so we'll use a P flag in our SSH command. Next, we'll use L for alias, which is our Bandit 0, so that's our first level. That's Bandit 10. Did I do 10?
Yeah. Jan, at the same time.
All right, and the password's given, it's Bandit 0. So now we are in a system. This is some server off in a server farm. And we'll do ls as Avi showed us. It'll list what is on our system, and we found readme. So we use concatenate or cat, and it'll show us the first password. So we'll go ahead and copy this, exit, go to Bandit 1. We'll go ahead and put in that password. And now we're on the first level. We'll go ahead and do ls. Now it's a dash. So if I remember correctly, we'll do cat dash. There we go. So dot dash is your main direct, your root directory. Or I'm sorry, dot slash is your root directory. So the dash was it was a file on the root. So to access that, we had to tell cat to go from the root to the dash. And then we'll go ahead and exit. And we'll go to the second level. So on the second level, go and put the password in, ls, spaces in this file name. So if we go ahead and try spaces in this file name, it will say no such directory because it thinks we're trying to open 4 different files. So to tell it that it's one entire object, we'll go ahead and put a quote around the file name, and that will open the file name. Instead of searching for cat for spaces, or searching for spaces, searching for in, searching for this, and then searching for file name. So let's go. Copy. And we'll go ahead and press up and go to the third level. And it'll ask for a password. Do ls. And now it's saying we're in here. Yep. So it's stored in a hidden file in here. So we'll go ahead and cd. So we'll change directory to the in here directory. Do ls to see what's inside. We don't see anything, so we'll go ahead and use ls-a. So this lists everything that's inside that directory. So everything that's hidden will stay out of a normal ls command. It's kind of a way of organizing things. If we use -a, it says, give me everything including hidden. So if we do ls-a, we're giving ... Those are home directories or root directories. And then we are given .hidden. So we will go ahead and cat.hidden. And that's our hidden password. And we'll go ahead and exit. And 4. ls. So we have another in here. Let's go to the instructions. So it says the password for the next level is stored in the only human readable file in the in here directory. So we have to search by the file type. So what I did was I went ahead and said file dash dash. So we're searching the files. Dash dash is like a command for it. And we're going to say any. Any. What this says is list out all the files. Oh, hold on. So first we got to be in the in here directory. And then it will go out and list out all the files. So we know that all these files are just raw data. It's ones and zeros or hex or anything that we can't read. And then we have the ACII text. So that's stuff you see like in a Word document or on a web page. So we'll go ahead and cat. Oh, it's dash. Okay, so we found that this is the only readable one. If we go to like 6, we get gibberish. I don't know what that is. It's not a password. So we'll go ahead and copy the password, exit, and then we'll go on to number 5. Number 5 is pretty hard at first. So we'll go ls cd here. So we'll hop in that directory, do ls, and let's go to the instructions. So it says the password for the next level is stored in a file somewhere under the in here directory. So we're in the in here directory. And it has the following properties. It's human readable, so it's ACII, that it's 1033 bits, and then it's not executable. So this one's doesn't really take much. So I think it's let me see what it is. It should be file. Yeah, file size. So we can search the file, and then we can search the sizes. So we could say 1033, and C is kind of notion for bit. There's a whole long list you can find online about what is what and how to format your query. So if you do, hold on, bust it. Oh, yep, I did. So instead of file, it's find. My bad. So we do file, we find size 1033C. We see that this is the one file that has the size of 1033 bits. We can also do this in other ways. So we can do human readable. So to do that, we find type, and F is the command for everything that's human readable. And it will give us all this. We can do things that are not executable. And I believe it's I don't know about that one. So we can also combine these, right? So we can combine size with 1033C and with this little pipe. So the pipe basically takes the output of the first statement and shoves it into the next statement. So there are really two commands that are split off. And so we could put dash type F. I'm mistaken. So we only use pipes when we're using two different commands. So in the future, we use like find and then grep. That's when you would use the pipe. This though, it's one command, so we'll just use different settings, and that should return the same file. And we'll go ahead and go to that file. We'll do CD. Actually, we can go ahead and be lazy and just go cat maybe here. spell. And there's our password. Okay. So yeah, so Find's a really useful tool. I use it at work. And it's really nice to just, when you have a big database to go through and figure out these little clues. So I'll go ahead and exit. Go to Bandit 6. And we'll go ahead and go to the next instructions. And this is similar. It says the password for the next level is stored somewhere on the server and has all the following properties: that it's owned by the user Bandit7, that it's owned by group Bandit6, and that its size is 33 bits. So the first thing that I really did on this is, you do ls-a, kind of see what all the hidden files are. And then I went ahead and did find-size 33C. And when you're on the root directory, you do have to specify the directory in which you want to go. So it won't let you just go out through everything. You have to pick where you're at, because really you're outside of the directories right now. So if I want to pick everything that's on the computer, I would just do // // and this would return sort of all the files that are of that size. So you kind of really have to look through these, and you don't really find anything. So you do user. Type Bandit7. We don't find anything. And we also don't find anything. Let's see how I figured it out. Bandit6. All right. So we'll go ahead and do. We'll try the other directory real quick. All right. So we'll go ahead and. Well, I swear I ran through these right before.
Try CD / here.
Oh, nah. There's no in here directory.
/ before I'm here. Oh, after my bed.
No.
I just looked it up and they did ls in here, then they did cd in here /.
All right. So let's do that. All right, group participation. You guys that got to 10, how did you guys do this?
We did, so you do the find and then you size 33C, and I did dash group 6 or dash group Bandit 6.
Do you have a directory on it?
Uh,
You should just be able to use a slash without a dot.
without a dot.
Okay, that's my issue. And it's somewhere in here,
It's the one you can access.
right there. Thanks. Go ahead and cat it. And there's our password. So you gotta be careful with those dots and slashes because that tripped me up also. So we'll go ahead and exit out. And now we're on the next box. So now this one, if I remember correctly, is we are searching for the word millionth. So how I went ahead and did this was I just did egrep. And egrep kind of really just searches through everything for like the keyword that you give it. So we'll give it millionth. And we'll give it a directory. And it should be data.txt. And it went ahead and found through data.txt the password. And if we didn't do that, we would end up having to go through this. That's really long. It would take a long time. Yeah, I can't find it. So we'll go ahead and egrep the password, copy it, exit, and on to the next one. So on Bandit 8, we have data.txt. The password for the next level is stored in the data.txt file and is the only line of text that occurs only once. So for this, I know we have to use the unique ID. So we'll go ahead and just see what is inside data.txt, right? And it's all this. So we also need to use sort. So sort will sort everything that's similar. Just kind of like that, how they're all bundled up together. But this doesn't really tell us anything. It doesn't really tell us what's unique. So what we need to do is, how I mentioned earlier, use a pipe. And we'll go ahead and cat data. So this is grabbing all the information, all these letters and numbers. And then we're going to throw it into sort. So then we're going to sort it. And we're going to use this thing called unique. So it's unique, really. UNIQ. And we're going to use the -u for the single unique. And this will return us the one that is like no other. That's in the stack. And that's our password. All right, so we'll go to the next one. We're almost finished. So the password for the next level is stored in the file data.txt and is one of the few human readable strings beginning with the several equals characters. So let's go ahead and figure out what's on here. So we have data.txt. We'll go ahead and cat data.txt. Very nice. Okay, so we actually can't cat it because it's not an ACII format. So we're going to use strings, which is a tool that helps us kind of just parse out things that are not human readable. And how it's kind of set up is it says a few human readable strings. So we know, one, it's kind of giving us a clue to use strings. And then two, it's kind of saying that these human readable strings are hidden inside of this kind of unreadable data. So we'll go ahead and use strings. We'll go ahead and select our txt file, and we'll go ahead and pipe it into grep, which, like we talked about earlier, is a searching function, and we'll search for equals since it mentioned it.
You've got 2 S's on the end of strings.
Thank you. It's like a lot of strings. All right, so it's a little messy, but as you can see, it's just kind of a bunch of randomness, right? But it tells us the password is, and then this. And we'll go and exit, and we'll head to the next Bandit box. Maybe I copied it. All right. So we'll go ls, see what it wants. And level 10 is that the password for the next level is stored in the file data.txt, which contains base64 encoded text. And to go ahead and undo that, let's go ahead and read what is data.txt. And let's see. What it is. D. Okay. 64. D. So if you don't know what how to use like a command like they give us like base64, gzip, bzip2, you can go ahead and use man. So you can do man base64, and it'll take you kind of like through everything. Or you can use base64 -- help, and it will tell you really quick what the commands are and how to use them and what they do. This works for any command, grep, cd, ls. That way, if you don't have any internet or you just need something real quick, you can quickly know what kind of commands you can use, or if you forgot one. So because we have base64 text file and we use the D, so we tell it to decode the data.txt file, it gives us our password. And that's the first 10 Bandit levels. If any of you were behind or you were just wondering how it worked out. So now we can go through 10 through 20. They do get a little bit harder, so we are going to get better. Cool. All right, and I'll probably just go through them on the screen, and you guys are free to do whatever you like. Cool. All right. Do we want to live stream this? Probably not. All right. Thanks for watching. Seriously, how do I go through that? I don't want to catch it. Just because it's the directories.